Good day, grade 8 students. Welcome to another learning episode in Mathematics 8. I hope you have a wonderful day. I am Teacher Daniel and I will be your learning buddy in exploring another fun topic in mathematics. Our objectives for today's lesson are the following. First, determine the inverse, converse, and contrapositive of an if-then statement. And second, illustrate the equivalences of A, the statement and its contrapositive, and B, the converse and inverse of a statement. To make sure you will learn and enjoy our math lessons together, please have with you a copy of your module, pen, and paper. So let us get started. Can you predict the consequences that will happen if a certain situation is given? Like for instance, if we vote for leaders with a good heart in a national election, can we predict the consequences that might happen in our beloved country? Let us challenge our bright mind in a short activity. I will be stating an if clause, a statement that expresses a condition, and you will try to give me a possible then clause or outcome of the phrase that I will be giving. Let's have an example. If we vote for leaders with a good heart in a national election, then our country will be in good hands. Are you ready? Don't worry, I will just be giving you simple statements. Let's start. For number 1, if Mount Mayon erupts, what do you think will happen to the people of Albay? That's right. Then many Albayanos will be affected. So putting together the if clause and then clause, the statement will be, if Mount Mayon erupts, then many Albayanos will be affected. For number 2, if Bulusan Lake is a tourist attraction, what will most likely to happen to this place? Probably, plenty of people will visit the place. Therefore, the statement will be, if Bulusan Lake is a tourist attraction, then plenty of people will visit the place. For last number 3, if Town Fiesta is a Filipino tradition, what do we expect to happen? Exactly. It will be celebrated every year. The statement will be, if Town Fiesta is a Filipino tradition, then it will be celebrated every year. What about if two angles are right? How do we describe them? Okay, if two angles are right, then they are congruent. You did a good job in our activity. Keep it up. Now, to realize the first objective in this lesson, we need to have knowledge of the following topics. Number 1, definition of a conditional statement. Number 2, transforming statement into if-then form. And number 3, related conditionals. In week 6, module 11, you have learned how to define conditional statement and identify the hypothesis and the conclusion of a conditional statement. Further, in week 6, module 12, you've learned how to transform a statement into if-then form. The learning situations and practice exercises help you be more familiar with how if-then statements are formed. That is by adding words to complete the thought of a statement after identifying the subject and the predicate of the sentence in declarative form, where we generate our hypothesis P and conclusion Q. Now, let us explore together the third one. Related conditionals. Let's begin. Conditional statements have three other related statements: converse, inverse, and contrapositive statements. Before we discuss these related statements, let us review on how to identify the hypothesis and conclusion of a conditional statement through the problem given. We have conditional: if P, then Q. If it rained, then the ground is wet. On this statement, the hypothesis is it rained, and the conclusion is the ground is wet. Note that throughout the discussion, we will represent the hypothesis as P and the conclusion as Q. To determine the converse of a conditional statement, we will just interchange the hypothesis and the conclusion. From the conditional, P will become Q and Q will become P. In symbols, it is converse. If Q, then P. Now, let's interchange them. It follows that the converse of the given conditional statement is, if the ground is wet, then it rained. To determine the inverse of a conditional statement, we will just negate the hypothesis, not P, and the conclusion, not Q. When we say negate a statement, we simply determine the opposite of that given statement. In symbols, it is inverse. If not P, then not Q. From the conditional statement, not P is it did not rain, while not Q is the ground is not wet. This means that the inverse is, if it did not rain, then the ground is not wet. Very simple, right? Now, let us proceed with the contrapositive statement. To do this, we will also negate both P and Q, just like what we did in getting the inverse, but this time, we will interchange them. In symbols, it is contrapositive. If not Q, then not P. Following the pattern, we have the contrapositive statement. If the ground is not wet, then it did not rain. We summarize our answers in the table. Writing the converse, inverse, and contrapositive statements is easy, right? Now, to master this skill, let us apply once more the same steps through another example. For example number 2, write the converse, inverse, and contrapositive of the conditional statement. Conditional: if P, then Q. If a triangle has no equal sides, then it is scalene. First, we identify P and Q of the given statement. P is a triangle has no equal sides, and Q is it is scalene. Now, we determine the converse statement by interchanging the hypothesis and the conclusion. We have converse: if Q, then P. If it is scalene, then a triangle has no equal sides. However, this statement is incorrect. But why? It is because even if we interchange P and Q, We must not violate the correct syntax of writing a noun and its antecedent. In this case, the noun is a triangle and its antecedent is it. So, the correct converse statement is converse, if Q, then P. If a triangle is iscalene, then it has no equal sides. Next is to get the inverse. At this point, P and Q will be negated. A problem that may rise is how we write not P because there is already the word no. Saying not no is incorrect. Thus, to get not P, simply remove the word no. Hence, not P is a triangle has equal sides. We follow the same procedure in getting the negation of a statement with the words not, cannot, and other similar words. So, inverse, if not P, then not Q. If a triangle has equal sides, then it is not iscalene. Lastly, we determine the contrapositive statement. Again, this can be done by negating both the hypothesis and the conclusion and interchanging them. Also, by following the correct syntax, we have contrapositive. If not Q, then not P. If a triangle is not iscalene, then it has equal sides. The summary of our answers is presented in the following table. With a given conditional statement, what if only one among the converse, inverse, and contrapositive statement is being asked? Can we give right away the answer? Yes, we can. We just follow the pattern shown in the table previously presented. Now let us try. In example number 3, what is the inverse of the statement? If you are 14 years old, then you are not qualified to vote in any government election. Knowing that the inverse is of the form if not P, then not Q, we first get the negations of both the hypothesis and the conclusion. The negation of hypothesis is you are not 14 years old, while the negation of the conclusion is you are qualified to vote in any government election. Thus, it follows that the inverse of the given conditional statement is if you are not 14 years old, then you are qualified to vote in any government election. In example number 4, write the corresponding contrapositive statement for if two angles are supplementary, then they form a linear pair. As defined, contrapositive statements are of the form if not Q, then not P. Here, we need to get first the negations of both the hypothesis and the conclusion and interchange them to have the contrapositive. The negation of the hypothesis is two angles are not supplementary, and the negation of the conclusion is they do not form a linear pair. Just like in example number 2, the words two angles and they refer to the same thing. So, they may be used interchangeably to conform with the correct syntax of writing a noun and its antecedent. Therefore, the contrapositive of the given statement is, if two angles do not form a linear pair, then they are not supplementary. It seems like we are getting deep with our discussion today. Are you ready to even go deeper? Let's go! Let us proceed with our second objective. The learner illustrates the equivalences of A, the statement and its contrapositive, and B, the converse and inverse of a statement. Equivalence is the state or property of being equivalent. It is used to describe members of a set, those that are in reflexive, symmetrical, and transitive relation with each other. But before we can identify which among the related conditionals are equivalent, we first need to learn how to determine the truth value of a given statement. The truth value of a statement is the property of being either true or false. It is false only when the hypothesis is true and the conclusion is false. To show that a conditional statement is false, you need to find only one counterexample where the hypothesis is true and the conclusion is false. Let us consider the related conditionals in example number 1. Conditional: if it rained, then the ground is wet. Is the statement true or false? Assume that the hypothesis is true. It rained. Then, it will be certain the ground is wet, which is our conclusion. Therefore, the conditional statement is true. What about the converse? If the ground is wet, then it rained. Let us examine if the statement is true or false. Again, assume that the hypothesis, the ground is wet, is true. Does it mean that the conclusion, it rained, is also true? Most of the time, yes. But we can give a counterexample that could make the conclusion incorrect. And that is when a water from the hose causes the ground to be wet. If this happens, then the ground is wet even if it did not really rain. Therefore, the converse statement is false. For the inverse, if it did not rain, then the ground is not wet. Let us again assume that the hypothesis is true, which is it did not rain. Will the conclusion, the ground is not wet, will also be true in all circumstances? No again. A water from the hose could make the ground wet. If this happens, then it makes the hypothesis true and the conclusion false. So, the inverse statement is also false. Now, let us go to contrapositive. If the ground is not wet, then it did not rain. Given that the ground is not wet, it is certain that all factors causing the ground to be wet did not happen. Therefore, it is certain that it did not rain. So, this statement is true. considering the truth values of the related conditionals, which among these statements have the same truth value? Yes, it is the conditional and the contrapositive, which we found to be both true, and the converse and inverse, which are both false. The findings that we have demonstrate the law of contrapositive, which states that a conditional statement is true if and only if its contrapositive is true. In example number 2, we have the statements as presented. Now let us determine the truth values of each related conditional. For conditional statement, we have, if a triangle has no equal sides, then it is scalene. The statement is true because a triangle with no equal sides is scalene. Next is the converse. If a triangle is scalene, then it has no equal sides. The statement is also true because scalene triangle has no equal sides. Next is the inverse. If a triangle has equal sides, then it is not scalene. This statement is also true because if a triangle has equal sides, then it may be an isosceles or an equilateral triangle. For contrapositive, we have, if a triangle is not scalene, then it has equal sides. The statement is true because if a triangle is not scalene, then it could be either an isosceles triangle which has two equal sides or an equilateral triangle which has three equal sides. As we notice in the second example, the conditional statement and the converse are both true. If this happens, we can form a true biconditional statement. A biconditional statement uses the phrase if and only if, which may also be abbreviated as IFF. In this example, we can form a biconditional statement, and it can be done easily by identifying first the hypothesis and the conclusion from the given conditional statement. Again, the given statement is, if a triangle has no equal sides, then it is scalene. The hypothesis is, a triangle has no equal sides. And the conclusion is, it is scalene. Now, we form the biconditional statement by just putting the phrase if and only if, or IFF, between the hypothesis and the conclusion. So, the biconditional statement that can be formed is, a triangle has no equal sides if and only if it is scalene. Or, a triangle has no equal sides, IFF, it is scalene. Very easy, right? To sum up our discussion, we have determined the inverse, converse, and contrapositive of an if-then statement. We have also illustrated the equivalences of A, the statement and its contrapositive, and B, the converse and inverse of a statement. Are you ready to answer the evaluation? With your paper and pen, you will be given 5 seconds to answer each item. Now get ready to answer the evaluation. Question number 1. How do we write the converse of a given conditional statement? Letter A. Negate both the hypothesis and the conclusion. Letter B. Copy the hypothesis and negate the conclusion. Letter C. Interchange the hypothesis and the conclusion. Letter D. Interchange and negate the hypothesis and the conclusion. Your time starts now. The correct answer is letter C. In writing converse statements, we simply interchange the hypothesis and the conclusion following the correct syntax of writing a noun and its antecedent. Question number 2. If there is a typhoon, then classes are suspended. If classes are suspended, then there is a typhoon. The second statement is the blank of the first. Letter A. Inverse. Letter B. Converse. Letter C. Contrapositive. And letter D. Biconditional. The correct answer is letter B. As we observe, the hypothesis and the conclusion of the first statement were only interchanged, forming our second statement. Therefore, the second statement is the converse of the first. Question number 3. Which of the following statements is the inverse of if it rains, then I do not go fishing? Letter A. If I go fishing, then it does not rain. Letter B. If I do not go fishing, then it rains. Letter C. If it does not rain, then I go fishing. And letter D. If I go fishing, then it rains. The correct answer is C. To get the inverse, we simply get the negations of both the hypothesis and the conclusion. The negation of hypothesis, it rains, is it does not rain. And the negation of the conclusion, I do not go fishing, is I go fishing. Therefore, the inverse of the given statement is if it does not rain, then I go fishing. Question number 4. Given the true statement, if today is Sunday, then it is a weekend day. Which statement must also be true? Letter A. If today is a weekend day, then it is Sunday. Letter B. If today is not a weekend day, then it is Sunday. Letter C. If today is not Sunday, then it is a weekend day. Letter D. If today is not a weekend day, then it is not Sunday. The correct answer is letter D. Applying the law of contrapositive, the statement in option D is the statement that has the same truth value in the given statement. Question number 5. What is the correct biconditional statement of a point has no dimension? Letter A. A figure is a point if and only if it has no dimension. Letter B. A figure is a point if and only if it has a dimension. Letter C. A polygon is a point if and only if it has no dimension. And letter D. A polygon is a point if and only if it has a dimension. The correct answer is letter A. Because the subject and the predicate of the given statement can be transformed properly into a figure is a point and it has no dimension respectively. How was the evaluation? Good job! I am expecting that at this very moment, you already have the clear understanding of the concepts we have just discussed. For more examples and exercises, please refer to your Mathematics Quarter 2, Week 7 and 8 modules. In reality, predicting the consequences that might happen in a given situation is easy because some of us have actually experienced them. Keep on doing every task given to you. This will help you upgrade the learning that you have. Even though we are not yet permitted to be together in school. We have just finished our lesson for Math 8 today. I hope to see you on our next learning episode. This is Teacher Daniel, reminding you all to always have a positive attitude and smile on your face.